Hello, so today we are going to talk about destructuring with using destructuring in Kotlin. So destructuring is basically a way where you can declare multiple variables at once. And this is basically you can declare these variables or unpack them from a list, from a data class, or from a class that you define your own, but by using a special technique in Kotlin. And so the first example is just using a normal list of two variables, and so of two values here. So I expect A to have the first one and B to have the second one. One thing to make to understand is that you can't do it like this. This should not work. So you can see it says inspected token because of this comma here without the parentheses. So you need to have the parentheses. And so if we run this, we should see 1 and 2, and that's exactly what we see. Now, what about if we add a third one? Let's see what happens. So you can see it gets ignored, right? Let's add more. 6. So the thing here is that it grabs only the available, for list specifically, it grabs only the available properties. So here, let's just print C to see what's there. So C ends up as 3, right? So it grabs only the values that are available and then it stops. You can also do destructuring with a data class. And so here, if I run just this here, let's say we have a student data class with a name and a grade. And so I just instantiate an instance of students, and we destructure it with name and grade, and we get these two we print them. So we should expect to see John and B+. And that's exactly what happens, right? So you may ask, why did it work for a data class? And why did it work for a list? And the answer is actually just, let's take a look at the output here. And the answer is in the definition here. So you can see this is sort of the what the Kotlin code gets decompiled to. And here, this is for the data class student, and you can see it has these two functions, component 1 and component 2. We don't have the implementation visible here, but whenever you have components, component n defined, when you define these, you can use destructuring. And so here, why we have only 2? Because we have only 2 properties that we can destructure on. So let's actually just test this out and maybe add, let's add a third property, maybe let's say course, right? And let's make this be a string. And let's have the course here, and let's print that one. Okay, and let's define it here. Let's say maybe it's math. Okay, let's run this. So we can still see that here. Now let's take a look at our class. So you can see now we have a third one, right? So as many properties as you would have the component definition for it, and that's what allows us to have the destructuring working here. So does this mean, one valid question you may ask is, does this mean that you can define your own? So let's try with a simple class. Maybe let's call this employee. And let's have that class with a name that is a string, and let's have maybe salary that is, let's say, an int, right? And let's try to actually just define one instance of that here. So this would be maybe something like this, and for the salary, let's say something like this, right? So would we be able to destructure this with just name, salary? Let's call this employee name, right? So if we take a look here, it says that destructuring declaration of type employee must have component 1 and must have component 2 for this to work. must have these functions defined. And so let's take a look at what functions, how they were defined. So it's just an operator function. So let's just try to define it ourselves, right? Let's just go over here, operator, so operator function, and let's call it component 1. And let's do one for component 2. And let's make this one return name. And let's make this one return salary, right? So this would be string here, an int here. Okay, so now you can see the error that we had here is no longer happening. So does this mean that, let's try to print these and see. So employee name, and let's do a similar thing for the salary. Okay, so if we do this and run, and now we are able to get the values. So you can even define it yourself, and you can define as many as you need. Okay, so here, just one additional thing you can do is you can use underscore if you, let's say you don't care about what's here. So you can use underscore, and we should still get the salary displayed correctly. And that's what we have here, right? Now you might ask, okay, what if we, let's say, what happens if we do it on the list? Let's see, and let's run, make sure our main here function runs test1. And you can see here, it ignores, again, this one represents only one value, right? So we've seen why does it work with student, because it's the compiler actually generates component 1 and component 2, and for this class we did define it, but for lists, what is the implementation of that? And actually, if you look at the standard library for Kotlin, in the collections file here, you can see that for a list of any type, Kotlin actually has a component function 1, which just returns the first element, right? And component 2 returns the second element. Component 3 returns the third element, and this should walk all the way up to component 5, right? But you can see here it's only up to 5 for a list, so there is a limit here. So I'm just showing you that you can destructure just up to how many component any do you define, right? So here, for example, for a list, because it's defined only up to 5, if we try, let's say, so I tried here to add 6, 7, 8 values, destructure 8 values from the list, it doesn't work. It says that component 6, 7, and 8 are not defined for a list of integers, right? Let's try with maybe just 6. It's still a problem with just 5, 3, 5. Here it should work fine, right? So yeah, that's something to take away from this definition. Another thing I want to show is also using these defining these destructuring operators as a extension function. So for example, if you have a class that you are using that is from another library. So for example, here for lists, it's common in a lot of languages to have sort of the first element, so maybe let's call it the head, and have the rest returned, right? So let's say maybe we want to destructure our list here to have just the head, and then the rest, and be able to assign a list like this. So if let's say we assign a list of 1, 2, 3, 4, 5, then what will happen is that head would be equal to 1, and rest would be the remaining elements, so 2, 3, 4, 5. So how do we accomplish something like this? Well, for head, that already happens by default with component 1 that is defined here, which gives us the first element. Now the problem becomes, what about for component 2? So what we can do is actually just create our own operator function, right? And override that component 2. And so how do we do that? Well, we just want it for every list. If you want to do it just for integers, you could just pass in an integer here, but we'll just define it for every list here. And let's call it component. It should be called component2. And it should return a list, right? Because the rest needs to be a list. And what do we want it to do? Well, we just want every element except the first one. And so in Kotlin, you could do that with drop, right? Which will just return a list containing all elements except the first n elements. So if we do drop 1, it will return all elements except the first one, right? And so if we do this, let's test this out. Let's put this function here, and let's say maybe 1, 2, 3. Let's have just head and rest, and so this would be head and rest. Okay, let's eliminate this. And this exactly does what we expected here, right? So you can define your own extension function for these. Now let's say also you wanted maybe to, since we were limited to 5 elements, let's say you wanted to have maybe 3, 5. Let's say you wanted to have 6. I don't recommend doing this because this is not very readable, but just to show you again how you could do this differently in different ways. So we have 5, let's say we want 6 elements here. And so what we can do is actually just define component 6, because we know the list was limited to 1. Was limited to 5, right? So we can just define component 6, and let's say we wanted to return just t, right? And we wanted to return just the element at position 5, because indices -1, right? And so if we do that, let's just print f to see that it's the last element. And let's run this. And that's exactly what happens as well, right? Another common usage for destructuring is with maps. So let's say you have a hash map here or a map here with keys, strings, and these as values. Then for looping through the map, you can destructure the entry from the map to key and value and just print those. So if we print this, let's just call this function. It gives us the key and value for each one. So why does it work? So now we know that it must be that component 1 and component 2, because we have 2 destructured here, are defined for the entry, right? Because if you just do a map.for, this gives you an entry value. So it must be that component 1 and component 2 are defined on a map.entry class, right? So let's take a look if that's the case. Here I have the documentation, so you can see we do have an operator function component 1 defined on entry, and that's exactly, so if we take a look at the code here, we do have component 1 and component 2 defined, and actually component 1 gives us the key and component 2 gives us the value, and that's exactly, that matches what we have here, right? So another thing to mention is that you can actually use this, you can actually use the fact that the entry here can allow you to destructure. You could also use it in Lambda. So for example, here we can take a map, a map like this, and we can just map the values to a new string, and we could use destructuring to have them like this. So if we run this, we should get 1, 1, 2, 2, 3, 3. And this is, by the way, different than a lambda with 2 parameter. So here it's not 2 parameters, it's an entry value. So you could do entry like this, and in that case you could do entry dot key or entry dot value. But if we do it like this, we are actually destructuring and not using the destructuring the entry value, and it's not 2 parameters. Now, one more thing I want to go back to and clarify here, one caveat is that, so let's take a look at the test case where we used it for student, right? Let's take a look at this use case here, and let's just remove the student one. So here, what if we change the what if we change the class? Let's say maybe the class student, data class student was defined in another file, and we changed it and didn't remember to change the call that initialized it here. So maybe let's say we added maybe year or graduation year or something. Graduation year. And let's call this a string, right? So you can see here, we don't have it here. We don't have it defined in our destructuring here. But the nice thing is that at least the IDE will tell you that the variable name doesn't match the name of the component, right? So let's try. So now it asks us to make that be graduation year, and so it just uses it suggests to us to use the same name so that at least we know what we are dealing with, right? And so here in this case, we also need to specify maybe 2026 or something, right? So that's just that's also something to pay attention to. So actually, what I would suggest is if you know your data class or your class values will change often, be really careful with the destructuring. But in some cases, it's really useful because, for example, with coordinates, let's say maybe coordinates, you would have only x and y values, right? So in this case, it makes sense to have have them, right? Yeah, just something to pay attention to. Yeah, so I think that's pretty much it that I wanted to cover for destructuring. Yeah, please like and subscribe, and see you on the next one. Bye.